So in the next series, we're going to be looking at the ideas of angles with respect to vectors. And so we're going to be taking a look first at 2 dimensions and then extend that to 3-dimensional vectors. And let's start by finding the angle between 2 vectors, u and v, where u is equal to 3, 1 and v is equal to 2, negative 1. So just to get an idea of what that looks like, if we were to construct that, so we have a vector v, which is 3, 1. Right? So from standard position, it might look like something like that. I know it's not perfect. And then 2, negative 1 is going to look something like this. So this is the angle theta that we're trying to find. Right? So if we get something like, I don't know, like 115 degrees, that's probably not correct. All right, now remember our formula for this. Cos of theta is going to be equal to u dot v divided by magnitude u, magnitude v. All right, and just assume those are all vectors, so that way I don't have to draw the carets or the lines over top. All right, so let's start by finding u dot v, and that might be the easiest thing every time you're asked to find this. So u dot v is going to be 3 times 2 plus 1 times negative 1, which is going to be 5. Magnitude u is going to be equal to square root of 3 square plus 1 square, which is root 10. Magnitude v is going to be equal to the square root of 2 square plus negative 1 square, which is root 5. All right, so cos of theta is going to be equal to 5 over root 10 times root 5. And there's a couple ways you could do this. At this point in your calculator, if you wanted to, you could take the arc cosine. All right, so you could just say that theta, and I'm going to erase this just so we have some room. So make sure you're in degree mode if you want to figure it out for the degrees. So you could say theta is equal to arc cos, and then in parentheses, you just put 5 over root 10 root 5. All right, so if you want to use a calculator, it's fine. This one, believe it or not, you can actually do without a calculator, because you could rewrite this as 5 over root 50, 5 over 5 roots of 2, if you were to simplify that, or 1 over root 2. And we know that cos of theta is equal to 1 over root 2 at 45 degrees. All right? And of course, you could just use your calculator. The calculator would say the same thing. So 45 degrees is going to be our pi fourths. All right. So hopefully that makes sense as to how to do this if it's an exact value. All right, and that makes sense if you looked at the diagram before. All right. A second example. Define u as 4, 3, v as 1/2, and then negative 2/3. Determine if u and v are orthogonal, parallel, or neither. And then if neither, then we're going to find the angle between the 2 vectors. All right, so again, start by finding u dot v. So that's going to be 4 times 1/2 plus 3 times negative 2/3. Right? So that's going to be 2 minus 2, which is 0. And we are done. Because if the dot product is equal to 0, we can right away say that these are orthogonal. All right? And the angle between them is going to be 90 degrees or pi halves. All right? And why can we say that? Well, remember at the very beginning of this section that we defined that if the dot product is equal to 0, then it just forms that orthogonal relationship. All right, so that's an easy way to be able to determine if 2 vectors are going to be orthogonal. And whenever you're doing these problems, I would recommend that you start by finding the dot product. A third example. Let's define u to be 023 and V to be 156. We're going to determine if U and V are orthogonal, parallel, or neither, and then if neither, we're going to find the angles. So again, start by finding U dot V. Now this time they're not going to be orthogonal because all of the terms are 0 or positive. So that's 0 times 1 plus 2 times 5 plus 3 times 6. That's a 3, not a 3i, as it might have looked. Or that's going to be 10 and 18, which is 28. Alright, so we still have a little bit of work to do. Magnitude U is going to be equal to 0 square, 2 square, 3 square, under a square root. So that's going to be square root of 13. Magnitude V, 1 square, 5 square, 6 square. Right. So that's going to be 37 plus 25. That's going to be, I think, 62. Or 26 and 36. Yeah, that's 62. Okay. So clearly they're not going to be parallel, all right, because there's nothing we can multiply the first component by other than 0 to get to 0 from 1. All right, so that's not going to work out. And clearly the other ones, there's no scalar. So it's not parallel, it's not orthogonal, so these are neither orthogonal nor parallel. And if we want to find the angle, we're going to use our formula that cos of theta is going to be equal to 28 divided by root 13 root 62. Or in other words, theta is going to be equal to the arc cos of 28 over root 13 root 62. Okay, and in your calculator, remember arc cos is that. I really don't like that notation because it might suggest that we're looking at an inverse or a reciprocal as opposed to the inverse function. Right, so bear with me one moment. I'm sticking this in the calculator. And I wound up with 9.51 degrees. Right, so these vectors are pretty close to one another. And that makes sense because none of these are all that far off. Okay, in fact, the 0 and the 1 make them almost laying on top of one another for those x components. All right. One last example is to be able to find the direction angles. All right. And again, let me draw what the direction angles are. So we have this vector v. Right, let's plot v in the three-dimensional plane. Now we are going to need a little bit of a negative going on here. So this is our x positive, y positive, z positive. Right. And if I was to plot 5, 3, negative 1, I would move 5 on the x-axis, 3 on the y-axis. Right, so we're just kind of stemming out here, here, and then we're going to move down 1 unit. Right, so just think of it in space, and we're moving down a unit, so it's below the z-axis. All right, now I'm going to erase all this. So let me get rid of some of this stuff that's messy that we don't need. Alright, so just think of that as just going below the z-axis just a little bit. Alright, and what we're trying to find is we are trying to first of all find alpha, which is this angle. We're trying to find beta, which is this angle. And then finally, we're trying to find our gamma, which is going to be that angle. Alright, so just conceptually what we're finding with this. Alright, notice none of the angles are all that large except for maybe alpha because we swung out a little bit there. Alright, so let's go ahead and find this. And remember, just to find alpha, remember cos of alpha is equal to V1 over magnitude V. and then we can find the others in tandem with that. So let's just go ahead, maybe find the magnitude first. So magnitude of V is going to be equal to the square root of 5 square plus 3 square plus negative 1 square. That should be root 35. Right. And at this point we can very easily find alpha, beta, and gamma. So alpha is going to be the arc cos of V1, which was 5, over root 35. Beta is going to be arc cos of 3 over root 35. Right, and again, 3 is coming from right here. And the last one we're going to have is negative 1. So gamma is going to be equal to the arc cos of negative 1 over root 35. All right, now I'm going to stick these each in the calculator, so bear with me as I compute. So for the first one, I got 32.31. For the second one, 59.53. And then finally for the last one, 99.73. Alright. So those are going to be our angles. Alright. And again, these are called the direction angles. They're just the angles that are going to be created from the X, Y, and Z axes. Alright, so hopefully this gives you a good idea as to how to work with angles and vectors, and utilizing the dot product as well as some of the other things that we've talked about with respect to vectors to help you to compute these.